In today's video, we're going to learn about theoretical probability. So the first thing we need to know is probability is the chance that something's going to happen. And if we're looking at theoretical, it's the theory behind it. So what we need to do is we need to know some facts about the events. The first thing we need to know is to work out the probability of any event happening is the number of ways for that event, so the number of outcomes, or number of ways for that outcome to occur, divided by the total number of outcomes. Alright, so I've written that formula up now. Now let's consider a dice, a basic dice. If we roll a dice, there are 6 numbers on the dice, so we need to know facts about that event. Now let's look at the probability of rolling a 6 for argument's sake. Well, the number of ways of achieving a 6 on the dice is 1, divided by the total number of outcomes altogether, which is 6. So we say the probability that we're going to roll a 6 is 1 in 6. What about if we're looking for a number greater than 3 on the dice? Greater than 3 means that all the numbers have to be bigger than 3, not including 3. So we're only interested in 4, 5 and 6. So 4, 5 and 6, that's 3 ways of getting a number greater than 3 out of 6 total outcomes. Cancel your fraction down to make sure you don't lose a mark. 1/2. So we say the probability that we're going to get a number greater than 3 on the dice is 1/2. Let's consider a spinner. Let's assume, I'm not great at drawing, let's assume this is a spinner and that all the sections are equal. So each outcome is equally likely. Okay, if something's equally likely, then it has the same probability for each section. So the probability that we're going to spin a 3 is 1 in 4 because they're all equally likely. So we say probability that we're going to get a 3, I've put an equal sign there, is 1 out of 4. I'm also going to stick with equally likely outcomes just and do an algebra example. I'm just going to clear some space. So on this one, I'm going to do a random experiment, has some results, and the outcomes are A, B, C, D, and E. Now for this, let's say A, B, C, and D are all equally likely to occur. E has a twice as likely occurrence as any of the others. So I'm going to do this algebraically, and we're going to write down what's the probability of getting E. So let's write down what's the probability of getting E. Remember, E is twice as likely to come up as the other 4. So I'm going to do this algebraically. Firstly, we want to work out what each of these is worth individually, apart from E, because we know that's twice. So we go, well, X is the outcome for A, B, C, D, and E. Well, E is twice as likely as the others, so I'm putting 2x. And we know that all the sum of the probability should add up to 1. So we do this algebraically, and we say, well, we've got 6x equals 1. So therefore, x is equal to 1 over 6. That means the probability of getting A, B, C, or D each is 1/6 each, which means E must be 2/6. Don't forget, you must cancel down your probabilities and you must write it so it's 1/3. We're just going to summarize probability now. There are 2 main characteristics for an event as total, and that is that each outcome in all of your events should have a probability greater than 0, but obviously less than 1. And that's because the sum of all your probabilities should also add up to 1. So the sum of all the possible outcomes should add up to 1. And that is everything you need to know about theoretical probability.